Okay, so today we're going to talk about transformation of linear functions. So your parent function is always going to be y equals x, or f of x is equal to x, meaning it can look like this as well. Okay, so you're always going to start there. Now in here, when we're in parentheses, we're going to do the opposite sign. Now the reason that is because if I were to take x plus 3, set it to equal to 0. The inverse of positive 3 is minus 3. So then I have x equals negative 3. So that is why we say to do the opposite. So for here, x plus 3, this would actually, because we went here, this would be left 3. We would just say that this automatically goes left 3. The reason it's left is because it's horizontal movement. It goes left and right. So for my students that kind of struggle, I try and focus on this. You see how 3 is trapped in the parentheses with your x. Well, domain is your variable x. Well, x goes left to right. So therefore, your in parentheses is going to go left and right. So on here, my x minus 3, opposite of minus is plus. So we're going to go right 3 because on a number line, if you were to do a number line, this is 0. Well, this is your negative side and this is your positive side. And if we're doing the opposite or the inverse of whatever's in parentheses, that's why we're going left when it's a positive and right when it's a negative. Then when we're not in parentheses, we're going to keep the same sign. So this is going to be like more of your vertical movement. This is going to be the one that goes up and down. You're like I tell my students that struggle here, you're not trapped in parentheses. So you're free to leave your x. You're free to kind of just stay and do whatever you want. Or another thing I say is you're trapped in the room with your ex. You don't believe anything they say. So you always do the opposite of whatever they say because they're your ex for a reason. So trying to make that connection and things like that. Here, like I said, you're not trapped in the room with your ex. So therefore, it's like, okay, cool. Like, I don't have to listen to you. So now I'm just going to walk away. Here, because it's a positive, we're going to go up 3. And because this is a negative, we are going to go down 3. So that's just how it's going to go. It's more of a vertical movement up and down. So here, when a is greater than 1, another way of seeing this is going to be g of x is equal to, it is the exact same thing if we were to put 3x. So when it's greater than 1, it's going to go steeper. It's going to move closer to the y-axis. So a general idea of what it's going to look like, because your parent function is going to go like this. The steeper it is, the closer it goes to the y-axis. So this, when it's bigger than 1, is going to go more something like this. So my black is going to be my parent function, which is x. My blue is going to be 3x. So it's going to be closer to the y-axis. So it's more steep, okay? Here, with a fraction, I have g of x is equal to 1/3 x. So again, your parent function is the one that goes directly through, right? So this is going to be your x. Now this one, it's less steep, so it's going to move closer to the y-axis. So it's going to look more something like this. So this is closer to the x-axis. Okay, so like I like to say, if you are, the older you get, the taller you tend to be, right? The smaller you are, right? You're smaller. So like I tell my kids, whenever you're taller, you tend to be thinner. So think about it like that. Whenever you're short, you get wider. So then there's your y, which is for the x-axis. Again, it's just a joke, guys. Don't take it so serious. Here, negative. Okay, so again, my parent function is going to be something like this. Again, my points aren't exact. Your negative is going to be the same exact, just reflecting over the x-axis. Okay, so it's the exact same thing except it's reflecting over the x-axis. Okay, so that's how you can transform linear functions. Now, here, these are two examples of what you may see on STAR. Just rewrite it. G of x is equal to x plus 2. So where this f of x is, you're just going to replace it with the x. Really and truly, you can do two things. You can take each point, because it's not in parentheses, and you're just going up 2. So you start at 0, 0, you're just going to go up 2, and then you're going to plot that point. Here, you're going to go up 1, 2, plot that point. Here, you're going to go up 2, plot that point, go up 2, plot that point, and then this is going to be your new line. Now, if you were to graph this, let's say you were to graph this, right? You would graph it. So the type of calculators that we have are going to be the TI Nspire. So you would graph it, and then you would click Control T to get a table. So the table it would give you, it would probably have the f of x. It would give you 0, 2. It would give you 1, 3, 2, 4, and 3, 5, which are exactly the points that we just plotted. So again, you can do either way. Just knowing just those transformations is going to be the best help. So with or without a calculator, it's the exact same thing.